Welcome to the video where we're going to walk you through a quick introduction to the select statement and focus mainly on how we select from a single table. We're not going to be discussing joins in this video, but we are going to talk specifically about the basic select syntax, and primarily we're going to focus on the select portion. We're going to get further along into the where and order by in a subsequent video. And as we start talking about the keyword of using the keyword join to join multiple tables and select from multiple tables, we'll get into the from. So let me uncomment these real quick. If you don't have this knowledge yet, you can use a PC to hit Control / and on a Mac, I think it's probably Command or whatever the control button is for y'all. Again, if you want to select a certain set of text, you can just hit Control / Control / again, and that will uncomment that, so you can select whole portions of code and undo that, or kind of toggle your comments on and off. You can do that in most IDEs like Sublime, Atom.io, regardless of the language you're coding in. That I find that to be the standard of just Control / will comment out a group of code. So I've uncommented this just to show you the 4 keywords that we're going to start with. The select statement will always have typically these kind of 4 things, or really at minimum these 2: select, from, and then you'll also see where and order by. So for the purpose of this video, we're only going to focus on select. When we get into joining tables, we'll start talking about the complexities of how you can use the from clause to update how you select from multiple tables. And in a subsequent video, we'll also talk about the where and order by. So I'm going to show you some examples today that have where and order by in them, but don't worry about them if they don't make sense. We're going to get further along into that in the next video. So in the book, I'm going to walk you through the examples from the book, and my goal here is just to let you see how I interpret the code. When I'm refreshing myself on SQL, I will typically walk through a text like this and I will run the statements, because the statements that are in the book are going to basically show you, here are all the things that you can do with SQL, or at least a major sub-selection of everything. And as I run the code from the book, it kind of makes me, question syntax and think about, well, can I do it this way or can I do it that way? And it lets me play around with it. And I recommend you do that as well. So the portion in the chapter, the Muroc chapter 3 on the basic syntax select, this is probably one of the most basic select statements that you'll see. And I recommend that if you're going to start working with a table, let's say we're working with the invoices table and we want to get some data out about invoices. I highly recommend, as you start to look at that table, which, if you open it up over here, we can see our table in SQL Developer, and you can see by clicking on the table, we can go in and we can pull up, the structure of the table, and you can even pull up the, data. Sorry, my computer's running a little slow here. So we can look at the data, but this is how you would do it through a GUI, and this is how I would honestly say a non-expert or a person with SQL skills would do it. So what we're going to do is we're going to just use SQL to pull data and look at the data and manipulate it. So if you don't know a shortcut in Oracle, you can just hit Control Enter, and that will run a select statement, assuming it is terminated with the semicolon. If you try to run a statement without the semicolon, it will try to run everything to the first semicolon. You'll get errors. So ending a single statement with a semicolon, it will run everything from that key select word to there. If I just select anywhere on here, and so let's run this statement, and what it did is selected everything from the invoices table. So in the select statement, in this line here, this is where we actually specify the columns that we want from the table. Now, if you don't want to specify and you just want to pull all the columns, you just simply say select star. Star is what we call a wild card, or an asterisk. An asterisk is a wild card, which means just pull everything. And so that's what we've done here, is we've selected every column from the invoices table. Now, as you may imagine, I could go in here and let's just take that exact same statement, but let's run it where we'll pull in the invoice number, we'll pull the invoice date, and we'll pull the invoice total. So we'll just pull these 3 columns. If I run this statement here, you'll see that's exactly what happens. And for the purpose of this video, I'm not going to get into the details of order by because we will talk about it, but this example, they did allow you to actually sort it by the invoice total. And so you'll see here it's not in any sorted order. If we did add this order by in there, it will actually pull the columns from the invoice table that we specified, and it will sort it by invoice total. And I'll get into how we can sort ascending and descending in a later video. So let's go in here now and let's look at an example that retrieves two columns, but also retrieves a calculated value. Again, for the purposes of this video, don't focus so much on the where clause, so let's even just take it out, and I'll just comment it out. Sorry, there we go. We'll comment it out, and let's just run this statement. So what this is doing is it's actually pulling the invoice total, and then it's actually pulling the credit total plus the payment total. And if you want, we can actually go in and we can just go pull these columns. Let's uncomplicate this a little bit, and let's pull just the credit total, the payment total, and remember you do have to separate your columns with commas. And let's pull credit total, payment total, and the credit plus payment total from invoice table. And what you should see here is that we pull the invoice, the total, the credit total, the payment total, and the combination of these two. And you see here that, let's actually find an example where we have multiple values. Here we go. So we'll see here that we pulled a credit total, a payment total, and this is the sum of these two columns. So we'll talk more about arithmetic here in a second, but this is just the basic syntax. If you just remember anything, remember select, from, where, order by. We will get into other ones like grouping and having and some other different keywords, but for now, select, from, where, order by. If you understand those, you understand the major part of SQL. Okay, so let's get a little further along, and I think in this intro it even talks about how not only can we pull columns from a table and we can sort it, but we can also filter. So in this example here that we just showed you, we could say, hey, pull everything, but only for invoice ID 17. In this example here, it's pulling everything that have invoice dates between May 1st and May 31st. So you can use different operators, such as greater than or equal than or between, a lot of different operators, and we'll talk about those as we explore the where clause. Here's another example where you run something. This actually says all rows fetched. It says 0 in 0.0818 seconds. So what this is telling you is that no rows were returned in this SQL query. And if I were to go and sorry here. If I were to go in here and select from invoices and say where it's greater than a total of 50,000, I'm going to get nothing. But let's change that. Let's say greater than 10,000. And what you see is that we do have some here that have a greater than 10,000. So the reason we're not getting rows is that there truly is no data that has, there are no invoices that have an invoice total greater than 50,000. And I think the reason the book shows you this is that it wants you to be prepared for, if you do create a query and the query does not meet any criteria or no data meets that criteria, it's going to not return anything. So just don't be freaked out when you see this. Okay, so let's keep going along here, and let's talk about how you can, if you notice here, like earlier when I was running one of these queries, I got this weird looking title up here. So it said credit total, payment total. It gives me the names of the columns, but here credit total plus payment total is not a column in the table. It's actually a calculated value. And so what we did is that it just the response that Oracle will give you is that it'll just name the column whatever the arithmetic or whatever the formula actually was. And so it named the column credit total plus payment total. So what if we want to actually rename that and give it a more correct name, or I guess a better descriptive name? Let's say that. So we can do that a number of ways, right? And the book actually shows you a couple examples. So one here is it says, hey, we could actually go in here and if let's say I didn't want invoice underscore number to be the actual number, the actual name of that column. I want to name it invoice space number. So to do that, we use what's called the as keyword, and you can just say, hey, I want to select invoice number, but basically what you're saying here is as parentheses, and we put it in parentheses because if you're going to have a space, you do need to put it in parentheses. I believe that if you actually gave it, if you didn't put a space in it, you wouldn't have to put it in quotes. So let's try it like this. Let's do like, let's call it, I'm going to use a really bad descriptor here, and I'm going to abbreviate, which I don't agree with. Don't abbreviate because, nobody knows what INV num, but you could probably run it like this. Yeah, and it'll work just fine. But because we're going to put a date, because we're going to put a space in here, it is going to have to kind of, start and end the column name with quotes. So that way it knows how to process this space. So again, if I run this, and I put it in quotes, this is a much more readable column, and it's just more descriptive, and maybe it just looks nicer. And the other thing to consider too is when you are using the as keyword, it's best practice just to put it in quotes. You don't have to, because you can see here, they didn't actually put invoice as total, they didn't put it in quotes, and they didn't have to. So the question that I get from students sometimes is, well, when do I have to use quotes, or should I use quotes and not use quotes? You can honestly do either, but what I would just recommend is that if it's easier just to remember, always put it in quotes, and then you never have to forget. And that way later on, if I say total of invoice, if I add in spaces here, it'll run just fine. So the other thing too is that you can actually do all of that without the as keyword. Some people don't find this as intuitive because you would say select invoice and then put parentheses here, and it does the exact same thing as what we did up here. It just omits that as keyword. So the as keyword is optional. I like using the as keyword because for me, when I'm thinking about it, I'm thinking, hey, I want to select this invoice number, but as this kind of pseudonym or this, this renamed column. But you can do both, right? You can run it like this with an as keyword. I could take this exact statement here. I could actually remove it. And if I run it, boom, I get the same thing. But back to where you saw earlier, if we do not provide a name for a calculated column, you're going to get something that looks like this. And this becomes a little problematic when you're trying to run a report and you're getting these long column names. So what we can do is we can actually give this a name. And so actually, when we take an invoice total, this is the amount that we owe, this is the amount we have paid, and this is the credit we were given. So basically, if I owe $1,000 and I've made a payment of 500 and have a credit of 500, it should balance out to 0. And so what this is calculating is balance due. And if I run it like this, I don't know if this is going to work because I tend to like to put things in parentheses for order of operations. Let's see if it runs. It did. It ran just fine. Now, what I was talking about was that I could put this in parentheses, and then I kind of know, hey, all of this is going to get calculated and then renamed to balance due. And but this is better than what we had before, which was just giving this long column. So if you start to have questions like, hey, do I need to use parentheses or not? Do exactly what I just did, which is just, hey, I wonder what I need to, I wonder if it'll work this way. I'm going to go run it. And that's how you learn, honestly, what you can and can't do SQL better than reading it from a book. Okay, so that's how you rename a column. Let's talk about how we do string expressions. So string expressions, what we're talking about here is how do we group characters and varchars and, strings, which are just characters, non-numeric values. How do we actually join them and parse them and do different things with them? So if I were to go and run, let's say something like this, let's run this statement, and I'm just going to alter it a little bit and select vendor city states And actually, no, let's leave it how it has it. Or what we can do is let's just take this out. Let's take the vendor city and state, and let's pull it out. Now what the book is showing you here is that it actually takes those same values and it concatenates them. Concatenate, if you don't know, means just to merge these two values together. So like for example, if we store first name and last name in two different columns, it's very common that you would concatenate them into a quote full name. Now what you'll see here is that the way that we do that is we use this double bar symbol, and that is how we can join them. In Excel, you might remember this is actually how we do it. We use an ampersand. And I think in some tools we would actually do it using a plus sign, which doesn't necessarily make a lot of sense because you're not adding numbers together. But for SQL and Oracle, we use the bar and the double bar. And so we run that, and what you see here is that it now has taken these two values and it has merged them into a column called vendor city bar. And I don't like the name of that column, so I'm actually going to rename it to, something like city state, or let's call it city underscore state. Yeah, and that looks better, right? It's a better column name. Now, let's say we're thinking, hey, what if we wanted to add a comma and a space there? Well, to do that, you actually can select, instead of because there's not a comma or space in the table, we can actually insert what we call literal values, or you might call it a hard-coded value. And so what that's doing is we take the vendor name, the vendor city, and what's happening here is we're taking the vendor city column. We are then adding in we're concatenating that with a hard-coded value of comma space, and then we're concatenating that with vendor state, and then we're concatenating that with a just space. So that's all this is. And if you want me to do it, I'll take this space out, and let's rerun this for a second. You'll see here that space went away, right? So let's add a space in there. So what we're doing is we're literally merging city with a comma space, state with a space, city, the zip code, and then we're renaming it as address. And so this is how we've talked about how when we subdivide data up, it's easy to just merge it back together into a single column. So we wouldn't store a city, state, and zip all in one column because parsing it up is more complex, because we have to figure out, well, does a city have one word or does it have two, and do we separate at the comma, and how do we know where the state ends? So what we do is we separate it out into its own columns, and then merging it back together is very simple. We just use this concatenated value. If you want, play around with this. I actually kind of run through this, and I'll go through and let's actually take out. Let's call this as address, and let's run it. So as I go through here, let's go ahead and go add in a bar, and let's say, okay, vendor, I think, what is it? Vendor state is what it's called. Let's run it. All right, and then I want to add in, and let's just play around here. Let's just, boom, let's run that. So what you can see is that we can add in, as you're working with string values, I recommend you do what I'm doing here, which is write a little bit, run it. Once it works, add in another piece. Make sure that works. Once that works, then go and add in the next piece. Vendor sip, right? Let's run that. Okay, we got an error message, and that is because maybe I named the field wrong. All right, so this is why you write code in kind of pieces. I think we're going to the vendor table here, so let's find out what the vendor is called. Vendor zip code. There we go. I didn't do that on purpose. That was a perfect example of why we code a little bit and we build code incrementally. So instead of trying to write this whole entire thing out, which I think a lot of students tend to do, and then they get this error, I recommend write that right there, right? Or just start even with vendor city, right? And then from there, add in the comma, and then from there, maybe rename it address, and then just kind of build it out. And that's how the best way to go about doing that. In this example, what it's showing you is that it has a vendor and and it tells you, it actually goes in and adds a apostrophe, so it's making it a possessive. And if you want to do that, here's the thing that will sometimes kind of throw people for a loop is that, let's say I want to go in and I want to concatenate that with, vendor's name. So you might think, well, I'll put in a apostrophe here, and I'll add in, I'll concatenate it with the string of apostrophe s address. And if you run that, it actually will give you an error. Wait, hold on, we're running. So what the problem is it, you'll notice even when I'm getting this, you'll notice that this is all blue. And the reason why is that this quote here, it assumes that, hey, we want to concatenate with a space. It doesn't understand what this is, but then it thinks all of this is another string that we're trying to concatenate it with. So what we're trying to do is, if you're trying to put a apostrophe in the quotes, you actually have to put in 3 ticks. And I actually call these single quotes, but I actually also call them ticks. That's just what I was told to told one day when I was learning this. But I put the little tick in there, and so this will allow you to insert an apostrophe, and so it's like putting kind of like a little quote around the quote. So if you're having to deal with apostrophes, you might just have to, in some languages they actually make you, stick it in quotes, and they make you do it in different ways. But the book is just showing you, hey, if you ever do have an apostrophe in here, that's how you go about doing it. So let's run that one more time. And this just shows you, and it didn't rename the columns, but you could do that. Okay, so that kind of shows you how you can concatenate strings together, and even concatenate literal or hard-coded values in there to make it more descriptive. All right, let's talk about arithmetic expressions. So when we talk about arithmetic expressions, unlike string, which is just putting characters and letters together, arithmetic is typically doing math. And you may already know, depending on how you were taught, I was taught the rule of please excuse my dear Aunt Sally. You may have been taught PEMDAS, but that means that when we are putting arithmetic expressions together, they follow an order of operations. So the first thing that gets calculated is parentheses, then exponents, then multiplication and division, and then addition and subtraction. And so let's just go through and run this basic statement here. We've actually kind of run it already, but it's grabbing the invoice, the payment, and the credit total, and then it's grabbing these 3 columns, so invoice minus payment and credit, and it's renaming it balance due. You're going to get very familiar with this in this book using the balance due, because it's a common thing that we want to be able to know in an accounts payable system. Who do we owe money to? Like example here, you'll see, hey, this is a big invoice. We haven't made any payments. We do have a credit, which is good, but we still owe this much. So we kind of want to know which balance dues are greater than 0. So this is a basic arithmetic expression. It subtracts from different values or columns, can be subtracted or added from each other. You can also hard code in values. So for example, in this example from the book, it's grabbing the invoice ID. It's grabbing the invoice ID plus 7 times 3, and I'm not really sure why it does that. I think the point of it doesn't make any like business sense why we're taking an invoice number and we're adding 7 times 3. So I think it's just showing you the order of operations. But what would happen here is that because we follow standard PEMDAS rules, it would not add 7 and then multiply. It's actually going to multiply 7 and 3 first, and then it's going to add 21 to the invoice ID. So you'll see here it added 21 to this, and it named it order of precedence. Here, it will take the invoice ID, it will add 7 and then multiply by 3. So what it should be is 1 plus 7 is 8 times 3 is 24. So this makes absolutely no business sense, but it's just showing you how you can use arithmetic with these columns, and again, standard PEMDAS rules apply here. Okay, let's talk about how you can use what I call scalar or scalar. I actually don't know how you pronounce this. Scalar functions. Basically what this means is it takes in a single value and it responds with a single value. So a scalar function in Excel would be like sum or count, counta, average. You take a you feed in one set of values and you get something back. As we get further along, there are more complex functions that we will use to, you can feed multiple values in and get multiple values out. But for the purpose of this, think about it just like, there's the sum function, there's a number of different functions that we can use that just spit back one value. So in this example, this is a really cool function, and what it's used for is allowing us to parse strings. It's called the substring function, which if you think about it, it's saying, and we're taking a sub part or a small part of this string. So here we have the vendor contact first name, the vendor contact last name, and these are the actual values stored in the table. But then what they do is they actually go and they get the substring, which basically says go feed in the first name. And substring has 3 values. It needs 3 values to run. So let's even make this simpler, and let's just clean this up a little bit and show it to you. So substring is going to say feed me a value, and then what this is going to tell you is what part of the string do you want me to start at, and then how many characters do you want me to grab. I believe in Excel, if you've used that, it's called the middle function or mid function. But it's the same exact thing. So let me run this one more time. And what you see here is that it is grabbing the first letter of the first name. Let's play around with it actually, and let's have it go grab the first 2. All right, and let's see what happens. So you see here that this changes the length of how many characters to return. What this then tells me is what character do I start at? So if I run this, you'll see here that it's now starting at the second character, and it's grabbing 1. And so this is a very valuable function when you know, hey, I want to start at a certain position, and I want to grab a certain number of characters. Substring is a really great function. You'll use it when you're wanting to format phone numbers, or maybe you want to grab initials like the example is here. A lot of cool things you can do with it. So what it did is it grabbed the first character from the first name, it grabs the first character from the last name, and it concatenates them, you'll notice here, and then it renames the whole thing initials. And that's how we got this value. Pretty cool. So the next one here is the toChar function, and this one, this might be a little complex when you first look at it, but let's just break it down. As I run through this, I immediately notice that we are selecting the word invoice number and we're concatenating to the invoice number. So that's what this number is here. So it goes and gets invoice number, and it actually feeds in the actual invoice number. Then it puts in a literal value of dated, and then it is then inputting a date. Now the thing is if I go and select, let's say the payment date from invoices, and I run this, this is going to give me a date. But the problem is that this is actually storing itself as a date and timestamp. You don't see that time just yet, but it has a very particular value, and it's not a string, which means if I want to go and add it into this text, I actually have to change it to a character or change it to a string, and that's what the char function does. It says take this date and go change the data type to a character, and then format those characters in this format. So if you notice before, this is what the date looks like. It's actually the day, month, and year. But if I change it to a character and say format it as month, day, year, it actually goes and does that conversion for me. And then same thing for payment total. Payment total is actually a number. And so what's important to understand here is that we've actually gone in and grabbed literal values of a string. The invoice number, I believe, is a string as well, because it has letters and it's like a varchar. So we've strung all these strings together, but we can't string or we can't concatenate strings, dates, and numbers all in one. We have to basically say, look, if we want to pull a date and we want to pull a number in, we need to actually convert all of it to characters to make one long string of characters. So this value here is actually a string concatenated with a varchar, concatenated with more of a string, more like literal string, concatenated with a date that's been converted to a string or a set of characters, concatenated with a literal string of 4, and then it's taken this number and concatenated that, converted that to a string. So it's just turning everything into a string and concatenating all the strings together. And that's what it's doing here. So we made a nice, cool, like taken the data from the system, like we've taken the invoice number, the payment total, payment date. We've grabbed these values, which are not sensical when you look at it like this, but then we turned it into a really nice, clean report that actually gives us a little bit more readability to the data. All right. The next two I want to show you are the sysdate and the round function. So this is the invoice date. We're selecting that. What the sysdate function does is it's basically like a pseudo column. You can just go say, I want to go select the sysdate. So if I run it like this, it will return today's date. So it happens to be October 1st, 2019 when I'm running this. And if I go and rename that column, it will go pull in that date. And what you don't see yet, we haven't gotten to this yet, we'll get to this when we talk about dates and functions, or functions specifically, but it actually is pulling a time as well. You just don't see that, but we could format it and show it. And so here, I want to show you what happens if we grab the sysdate minus the invoice date. So if I run that, what you actually see is the sysdate, which is October 1st, minus the invoice date, which happens to be, I think, like 2014. So it's giving you the number of days since that invoice. So it's taking today's date minus a date in the past, which the date in the past is 2014. You're getting this really, really big number. But because it actually isn't landing on midnight, it's not the whole date. It actually includes minutes and seconds in here. It's giving you a decimal because it's actually 1901 days and kind of a half of a day, because I happen to be recording this in the middle of the day, so it's actually saying it's like 1900.5 days. So that's not a very nice, set of numbers. So what we can do is use this round function to take the results of this and just say, hey, go round it. And that's what this does, is it just rounds this up to 1902 days, and it renames it invoices in age. Pretty cool function, very useful function. If you're getting weird stuff like this, you might say, you know what, I'm going to use the round function. Same thing would happen if you're calculating like a person's age. If you take sysdate minus the birth date, you get a really weird number like this, because you're never going to be, unless you're running it exactly at midnight, you're not going to get a whole number. And so rounding is common. And then the mod function, what this is doing is it actually goes through and it grabs a value, and what it will do is it will, if you put in a value here, it will divide that value by a number. So let's actually do it like this. Let's take the invoice date and let's say divide it by 2. What it does here is it takes this and divides by 2, and it will tell you if there's a remainder. So here, if I divide 2 by 2, the remainder is 0. If I divide 3 by 2, the remainder is 1. If I divide 4 by 2, the remainder is 0. A common time, so this is why, like in the example that's running here, you'll notice here that all the remainders, like you divide 4 by 10, 9 by 10, but when you get 10 divided by 10, the remainder is 0. The most common use I've seen of mod is when I want to be able to figure out if a number is odd or even. You actually use the mod function and say divide by 2. If your remainder is 1, you know that number is odd. If the remainder is 0, you know that the number is even. So that's kind of giving you just a brief overview of some functions you can use in Oracle. The next thing I want to quickly show you is the dual table. So at times you might just want to run through and test out expressions or concatenations or things like that. And you may not want to actually use a real table. So you can actually go and select a literal value or an arithmetic expression, so a string expression or a arithmetic expression, or even a function like sysdate that will go and pull a value. And the problem is you can't just say select this and then run it, right? That's not going to work. You can't, because SQL demands that you tell it a table. So the dual table acts like a dummy table. It's just kind of filling in the syntax to say there is no dual table over here, you'll see. It's a fake table. It doesn't have columns on it. It's just kind of a way to say, hey, go pull from this dummy table and pull these values. So if you want to test expressions, like I want to test, let's add in an arithmetic expression here. Let's say, 10 times 10 times 2, or let's do something like this. So I expect this to be 20 times 2, so I'd get 40, And it's just allowing me to run this sequence of code and fill in this thing that we need. So it's kind of, again, it's almost like a dummy table that we use to complete the syntax. And it's very useful when you are going through and testing out expressions. All right, next thing I want to hit really quickly is the distinct keyword. This is actually really simple. It's just a way of removing dupes. If you've ever used Excel and used the feature called remove dupes, it's basically what we're doing here. So I'm going to run this first statement here where it's going to go and grab the vendor city and state from vendors. Now you'll notice we have some dupes in here, and that's because if you actually go look at this statement and run, you'll notice that the first two happen to both be from Anaheim. So they're two different vendors, but they're both from Anaheim. So if I go and select this information and say, give me the city and state, it's going to show you that there are duplicates. Now it could be that maybe you want to know all the distinct list of cities and states that you have in the vendors. Now right now there's 122 columns here. You could even figure that out by just going and grabbing a count of every column. Oh, well, actually, we're not going to get to that just yet. Ignore that I just did that. So I'm jumping ahead. But we could actually go and just see the count right here. If I scroll down, you'll see it gets to 122. Sometimes when you first run this, it's going to grab the first 50 records because it loads quicker that way. Eventually, it will finish loading all the records. And if you don't see it update, you can refresh, and I think actually it slow loads it so it doesn't grab everything. But if you scroll down to the bottom, you'll see that it's 122 rows. But again, we have a lot of dupes in here, so what we could do is we can just simply add in a distinct, which says only pull the distinct values. So if it sees that Anaheim, California is in here twice, it would just remove that duplicate. So let's run it one more time, and that it did. And when I scroll down, we actually get 53 rows now instead of 122 because it basically gave me a distinct list of the city-state. All right. Last thing I want to go over here on chapter 3 in terms of the select column is using this pseudo column known as row number. And this will get a little bit more complex. I'm going to show you these other examples that are in the book, but some of them may or may not make sense because we haven't gotten to subqueries yet. For some of you, but basically what it's doing is if I go and select the vendor ID and the invoice total like they're doing here, you'll notice this column over here that is not stored in the table. This is the what we call a pseudo column, meaning that it's just a column that it actually kind of virtually exists. When we pull a query back, it will just give me an automatic row number. And the cool thing about that row number is that we can actually use it in our queries. We can actually refer to it and say, hey, go pull this set of invoices where the row number is less than or equal to 5. And I could change this to less than or equal to 10, right? And it would pull, again, the first 10. Now, the one thing about this is that because I'm just saying grab these values here, it's just going to grab it in the order that it exists. So if the order, if these were entered in this order, it's going to grab these first 5. But maybe you want to potentially sort by invoice total. So what we could do is we could grab these first 5 values, and it looks like it's trying to run this statement. Let me cap that off. So what we could do is grab the first 5 values, and here they are. And now I could actually go through what the book has an example of is that if you grab the first 5 values and then you want to sort it by, let's say largest to smallest, so that's where we add in this descending keyword. Again, if you haven't gone through order by yet, don't worry about that. But what this is simply doing is grabbing those first 5 and then sorting it descending. But you may want to, instead of just grabbing the first 5 columns and then sorting it, or the first 5 rows and then sorting it, you may want to sort the whole data set first. So what this would do is we could actually go in and let's grab this, let's grab all the invoices. So here it is, 3410. What if you wanted to sort it first? So you could actually sort it first. So we sort by invoice total. And then we could grab the first 5 of this. And so what the book was kind of showing you is that, you could actually grab the first 5 records and then sort it. Or what you could do is you could actually go grab you could actually sort all of the invoices and then grab those and grab the first 5 rows of that sorted list. So what you'll see here is it's going to give you a different value. This will make a lot more sense once we go further into the where clause and order by. So again, if you haven't done that part, don't worry. I just wanted to kind of quickly touch on these because they were in the book. But at this point, that's where we want to stop today, and I hope that was helpful. If you have questions, post on the discussion board and let us know where we can help.